Connecting f prime and f double prime with the graph of f.
I think I had a little piece of like tandem sharp piecing or something after. Cause like, I think I started like walking kind of weirdly cause it kind of felt like I like was feeling it.
Whoa, why is this so blurry?
I don't know.
Okay. All right, so we looked at yesterday with the notes the first derivative test for local extrema to find where it's going basically to be a max or a min by just looking at the first derivative. Josh is being weird. And so if the sign changes from positive to negative at the critical point, then it's a max. If it changes from negative to positive at the critical point, then it's a min. So these first ones say to use the first derivative test to determine the local extreme values for the function and identify any absolute extrema. So number 2. Y equals negative 2x cubed plus 6x squared minus 3.
One of these times, I kind of want to see what happens when you let it do the suggested whatnot.
It's just annoying.
Is yours doing it too?
Yes. It's like putting my Y's in like boxes and stuff. And,
It's not smart enough. Like, that's the
No.
problem. Like, it can do basic. Okay, I understand. I won't talk bad about you. It can do like basic things, but it can't do like hard things.
Yes.
Like, it can do 2 plus 3, but it can't do like the square root of 75. Like, it doesn't understand.
it's just
Does it know the square root of 64?
I don't know. I'm just saying, like,
I mean,
it's just annoying. Anyways.
why crying?
All right. What is the first derivative of this function?
You got this, Virginia.
Hold on. Negative 6x squared plus 12x.
Yep. So then as far as setting it equal to 0 and solving, I would probably factor out first. So I would take out
That's smart.
Thank you. So I would take out a negative 6x and be left with x minus 2.
Honestly, though, I might not have thought about factoring the negative 6x. I mean, maybe on another day I would have thought about that, but
It's that.
not today.
All right, so I basically end up with, when I set each piece equal to 0, x equals 0 or x equals 2. Did you just get mad at that piece of paper?
I
get
don't,
mad
I
at
don't
your
even
iPad.
know.
What the heck just happened?
I just looked up and was like, what?
Bro, what?
What did that happen?
It did not look like that before I said something about the paper. I swear.
So I was like, there's no way that you noticed that and like didn't say anything.
I hope that this video saves because
I know, it's scaring me because it's glitching.
I want to see like
I
when
need to
it
see how that
happened.
happened.
Okay, so now is where we do our sign chart because we're using the first derivative test. I mean, you can obviously do it different ways, but I think the sign chart's the easiest way to see it. So I usually just will create the little doohickey here. Also, was watching that show last night, and the girl on there, so like, I don't know, like, I say this sometimes, I don't know if I've ever said it to y'all, but I'll be like, okie dokie.
Mhm.
So this girl, she says okay doke
Oh.
instead of okie
Okay
dokie.
Oh.
She says okay doke, and I was like, what?
Wait, what show was it?
The-
Local Spectrum?
Yeah.
Oh, okay. Now other people will have context.
But it was just like so random. But I mean, like different people say different things. But I just thought it was so. I was like, did I hear that right?
Some
Like,
say like okey doke, but like okay doke.
yeah, it was okay, doke, and I was like, what?
Like what?
I was so confused.
Alright then.
Anyways. All right, this is the sign of y prime, just for reference, because when we get into the concavity test, it will be in the second derivative. So if I choose a number in this interval and I plug it into the first derivative, okay, so if I plug in -1 to the first derivative, do I get a positive or a negative number?
You got this, Virginia.
Josh has no idea.
Wait, if we put like a positive in?
Oh,
A
fine, I'll say
-1.
Wait, what?
If we plug in -1 to
Yeah,
the
I say-
first
I
derivative.
say it's negative.
So -6 times -1 squared plus 12 times -1.
If we plug a -1 in, then it's gonna be yes, negative.
It's gonna be yes.
Yes, it is
Yes.
negative.
Yes.
What if I plug in +1?
Then positive.
Positive. What if I plug in 3?
Positive. No, negative.
Negative. Now, typically they do alternate, but that's not always the case. Okay, because we did have the one situation that talked about option 3 was if the sign does not change, then there's no local extreme value. So just keep that in mind. All right, so it changes from negative to positive. When that happens, is it a min or a max?
Min.
Yep. So there's a local min at x equals 0. So in the original equation, if I did f of 0, I would get -3. So it's at the point 0, -3. Now, which way are they asking for answers?
All of the above.
Just skip like 3 pages to find the answers. Rude. Okay, the answers are that's weird. The answers are in XY coordinate notation, just for reference. And then if I go from positive to negative, what is it? Yep, local max at x equals 2. So f of 2 would be, why am I struggling with this? -16 plus 24, so is that positive? 8 minus 3 is 5. So it would be at 2, 5 would be our max. I don't understand this. I don't even know where the answer to this question is in my book. I'm so confused. It literally says the answers to these questions, see page 222 for 1 to 3. Oh, maybe it is over on that page. 5 and 6. But one question, the answer is on that page. I don't understand. Okay, I don't know. We're just going to disregard.
Okie dokie. I mean, okay, dokie.
Okay.
I feel like every time I go to like type that now, because like I'll send okie dokie a lot, like in a text message instead of just saying okay. I don't know. I feel like okay is just kind of like eh.
Like,
It's just like,
Kind of like I almost feel like it's rude, but like it's not. It just I feel like it is sometimes. So I'll just
sometimes okie dokie sounds a little sarcastic.
I usually say okie dokie. Like I'll be there.
I just can't say just like okay. Like I have to add some letters. Like I'll say like okay.
So you'll say like, okay, AY.
Okay, okay.
Okay. Okay.
I'll have to tell you about something else that happened on that show later too.
Oh no.
I need to watch. I need to get back into it.
I was weak.
It was
Literally,
so
Kenny
good.
and I were like, we're done.
I need to watch it. Remind me.
Okay. Next time I'm watching an episode, I'll text you.
Yeah, like,
I won't watch one tonight. It'll be too late.
yeah, I know.
Maybe tomorrow I'll watch one. I don't know. We'll see. All right. I need the first derivative of this. What is this?
Product.
And
One of those E's, so that's a chain.
yep, product rule and a chain rule. Can y'all hear my headband?
Yes.
Now that you say it, yes.
It drives me crazy. Every time I move, I hear it.
Sounds like grocery bags.
Yeah, it does kind of. Okay, anyways. So what's the derivative? I thought you said Josh.
I'll let
I'm
you
figuring
take
that
this
out
one.
right now. Alright, so far I have e to the 1 over x plus, I'll say, negative e to the 1 over x. Is that sounding right so far? Isn't 1 over x the same as x? No, that's not negative x. That's x to the negative 1.
That's why I was like, you're kind of right, but kind of not.
Yeah.
So it's always the derivative of the first times the second
Mm-hmm.
plus the first, so we have an x, times the derivative of the second. What happens when we have e to the anything?
You just copy it as it is.
So it's e to the 1 over x and then times the derivative of whatever is up in its exponent. What's the derivative of 1 over x?
Negative x to the negative 2.
Yep. Or you could say negative 1 over x squared. Either way.
I think I like the negative 1 over x squared.
Well, that's how it.
Then we can cancel x's and that.
Well, I can still cancel like this.
Right, but it brains easier.
Well, then you should have said the answer.
X to the first minus 2 is x to the negative 1. I don't have to write it that way to know.
Fine.
I'm just messing with you. I don't care how you want to write it. You can do it.
It's a battle. I don't even know what was going on. I just knew something was.
E to the 1 over x minus e to the 1 over x would be what's left over. Once I reduce my exponents. I don't think Josh liked my method.
Whatever.
So then I factor out an e to the 1 over x. Would you have thought to do it this time?
Yeah, I was literally going to factor that out and then you did that other thing and it's like,
So this is e to the 1 over x times 1 minus 1 over x. So now I've got to find where this stuff is equal to 0. Or where there's any problem children. Alright, so e to the 1 over x times 1 plus 1 over x is equal to 0.
Wait, why is it a plus now?
I don't know. Because I wrote the wrong thing.
I thought it was just
Sneezing
some sort
yourself.
of.
I don't know why it was a plus.
I thought it was just part of the problem. I thought we were checking like the positives and the negatives or something.
No.
Hooray!
hooray.
I knew that.
Of course you did. Really
Calling me out for stuff.
Yeah. I'm just a mathematician.
Then tell me where this is equal to 0.
Oh, let Josh take. I mean, clearly I know what I'm doing, so maybe I'll let him take that. You got this, Josh.
Hold on. Okay, now I'm gonna say that x equals 1.
What?
Okay, so if I subtract 1, then I get -1, and then multiply by negative, I get +1, and then I can flip it, so I
Okay,
get
so I did that wrong.
x equals 1.
That was just too much. I was trying to do it in my head. I was like, no. No.
Okay, now, I don't think that the other one can equal 0.
Okay, but
I don't know where that would.
are there any other problem children? Virginia, I'll let you take this one.
I will too. Oh, absolutely.
Like
You
if
got
we
this.
plug it into the original, that make it like not work.
Plug it into the original.
Like, cause when we find the x's, are we plugging it into the? Oh, it's wherever x. Wait. What about?
Where would there be an issue in the domain?
I don't know, like, so we
What happens when I divide by 0?
oh yeah, well, yeah, we remember that, it's undefined, but is that,
Okay, so that would also be a problem.
oh, okay. That's what you were talking about with problem children. Okay, so not Virginia Valley.
What? I don't understand.
You didn't get it? You didn't understand
No, I
why I was
didn't.
looking at you?
No, I get that part. What are we trying to spot right now?
I just want to specify where there would be a problem. Because now they don't actually account for that in their mins and maxes, clearly, based on what I've got here, but
So
there
what
will be a
happens-
sign change at that number.
So what happens when your exponent is undefined? It's just like, panic.
Pretty much,
Same thing as regular undefined.
basically.
So it just can't be x equals 0. So like.
But it can't be x equals 0 in the original either,
Okay.
which is why we're not going to be able to have a min or a max there.
So with the e to the 1 over x, we just don't use that.
There's no values that are going to make that 0, technically. Because log base e of 0 would be equal to 1 over x, and you can't have a log of 0.
Would we need an imaginary number?
An imaginary number?
Yeah.
I don't know about imaginary, but
Like to make
perhaps.
that thing 0. Since like real numbers aren't working.
And then it just isn't 1.
I mean, I wouldn't want to have to deal with the imaginary numbers. They can be kind of scary.
So I usually just out to the side, I don't necessarily write sign up. I just do this so I know what it's getting plugged into. Because if you plug in -1 to the original, is it positive or negative? I mean, not the original, the derivative. It's positive. If I plug in like 1/2,
Negative.
2.
Positive.
So, if I were to use 0 in the original, that causes a problem. So this can't actually end up being a min or a max. Okay? But it does change sign there. It's just something different happening. But over here it goes from negative to positive, so what is that?
Min.
Yes, I have a min at x equals 1.
I couldn't tell you why I said it like that.
F of 1 is what? So if I plug in 1 to the original, what do I get?
E.
Yes.
E, yes.
So 1e is where the min occurs.
One.
All right, concavity test. So this is where we're looking at the second derivative. If the second derivative is greater than 0, it's concave up. If the second derivative is less than 0, it is concave down. So we'll basically be doing the same thing, but we're setting the second derivative equal to 0 and solving, and then using that to determine if it's concave up or concave down.
I'm just realizing we've only done 2 problems. That's it.
That's what happens. We don't really do that many once we get to this point. It's just takes a long time.
So, they're all problem children, is what you're saying.
Sorta. Concavity test is kind of fun though.
Take out
Until
the
you
top.
have to do all of this stuff in one problem, it's fun
When do you do that?
In your nightmares.
on the test.
Same thing.
All right, 8. Y equals negative x to the 4th plus 4x cubed minus 4x plus 1. So I find the first derivative.
Wrong problem.
Huh?
Don't you just hate it when you write the wrong problem?
Yes.
Now, of course, I wouldn't know if you wrote the wrong problem because I don't have my book open. But I hate it when I write the wrong problem because then I have to redo it.
I wrote a wrong middle term the other day for a problem, and when they graphed it on their calculator, it was one of those where you're finding all the zeros and stuff. And when they were doing it, we had found like where all the zeros should be, and then we were like looking at it, and they were like, these numbers don't look like anything that we have written here. And I looked and I was like, oh, it's because I wrote the wrong middle term.
Oops.
Which I didn't know that the wrong middle term could make that much of a difference, but it did.
I mean, if you think about it, doesn't it kind of shift the whole graph a little?
I mean, yes, but like, I didn't realize that it would have, because the factors that you get are from the first and last term. So I didn't realize that the middle number being off by like a little bit was going to make that much of a difference. But it made we should have only had whole number zeros, and it was giving us fractional ones, and I was like, oh no. Yeah. Anyways.
What class was that?
Jinx!
You said what class was this? I said what class is this? That's not the same thing.
Suck. You suck.
Algebra 2.
That means you owe me a soda.
I don't owe you
Lemonade.
anything.
No, you owe me one of those lemonades.
I don't owe you anything.
You owe me a $150. I mean, like
$150. Okay.
I'm not giving you $150.
First derivative of this. This is why we don't get through so many problems.
I already did my derivative actually on my
Oh, good. What'd you get?
negative 4x cubed plus 12x squared minus 4.
Beautiful.
Just for treating you.
Second derivative.
Oh, thanks. Oh, wait, the second one?
These we're doing the concavity test, hon.
I did not get that far. Oh, darn it. I got this. Negative 12x squared plus 24x.
I'm just wondering what plus is.
So now we need to set this equal to 0 and solve.
Oh, we set that equal to 0.
Josh.
Okay, we factor out.
A what?
Do we want to take out the negative 12? X or just
I would
12?
recommend it.
Okay.
If I negative 12x, you're all on your own.
Gosh, I keep writing the wrong sign.
Oh, well, I guess that's better than just writing negative 2x.
So I get x equals 0 or x equals 2.
That sounds familiar.
Now I do a sign chart for those numbers, 0 and 2. And this is going in the second derivative. Normally I'll just write y double prime, or if it's like actually written in function form, f double prime. So if I plug in -1 to the second derivative, what do I get?
Negative.
If I plug in 1, what do I get?
Positive.
3?
Negative.
All right,
Is it
so
okay if I use the one with the factored out thing for that?
it doesn't matter.
Okay.
So now we're looking for where it's concave up and concave down. So concave up is anywhere that the second derivative is greater than 0. So anywhere the second derivative is positive, it's concave up. So that's going to be from 0 to 2, not including. And we're concave down where it's negative. So that's going to be from -infinity to 0, union 2 to infinity. And all of these will be not including because we can't have it where it's actually changing sign that doesn't deal with concavity.
I feel like I remember doing this like last year or something.
Well, we wouldn't have been doing it with derivatives, but we did do
Yeah.
sign charts and stuff like that, and then analyze where it was positive, negative. And that's why people are like, why do I need this? And I'm like, well, you don't really need it now, but you will later.
Besides like today, I kind of forgot when the last time I used a sign chart was, but I think it was
Pre-cal.
between now and recalculus. I don't remember if I used it on the SAT or something.
I definitely didn't. I can tell you that right now.
I think I might have.
Why is he honking?
Oh, it might be because the kids are out at recess and they might have been looking at him to get him to honk.
Because I thought I heard some kids go, after you did it.
You mean like,
You almost had it.
yeah,
Yeah.
on a good day I might have it. Needless to say, today's not a good day.
I think he's doing it on purpose.
I agree with that noise though.
Yeah.
All of the
he's
above.
exited.
I agree with the honk and the squeak.
I'm really glad they were able to take them outside because we have all the stuff set in the gym for homecoming, and I was like, ah!
That would be.
I'm sure they'd make the same sound.
Probably. Mr. Fletcher was like, they'll be throwing like balls everywhere and probably hit everything, and I was like, can they please not
No.
come in here?
Please no.
Can they maybe play like line tag or something where they like have to stay on the lines? Like,
Exactly. Just anything.
I thought you just like knocked your drink over.
all right, first derivative.
Is it 1?
Each of the
Wait,
X.
darn it, I'm so bad at these.
Second derivative.
E to the X.
You want to keep going? No.
Yes.
All right.
Each of the X.
Now set this equal to 0 and solve.
No. No.
Okay, there's nowhere, but what do we know about e to the x as far as its graph? It's
Oh.
always what?
It goes
Greater
up.
than 0.
Oh.
Ah.
And it's always going up, so.
So it is always positive.
Such an optimistic graph.
concave up. All right, so we're not going to do it today, but just so you kind of get like a little preview of where we're headed next week. I'm hoping we'd be able to wrap this up on Tuesday, and then we're going to be looking at a quiz probably Thursday. If for some reason we don't have school, then we'll just play it by ear and see. If we don't have school Wednesday, we'd probably still try to have the quiz on Thursday, unless y'all just have like a surplus of questions, just to like get through material. But the next thing that we'll be doing is finding points of inflection, which basically it's a point where there's a tangent line and the concavity changes. So we will find the first derivative, find the second derivative, set it equal to 0, and solve. And then we'll be determining, does the sign change? And if it does, then the concavity is changing. So like this one, this would have had points of inflection because the concavity changes in each of these things. And so there would be a point of inflection here, but we have to take this number and we plug it into the original to find where the point of inflection actually occurs. So, anyways, we'll be doing that. And then we'll also be doing stuff where we'll be determining if the particle is moving left or right and accelerating or decelerating with a sign chart.
I think the particle is just a particle.
And then we'll use the second derivative test kind of formally, which we've already been using it because I don't see a point in waiting to teach it to you and teaching you their crazy method that they use in the first section. So why we started doing the second derivative test so quick. So we'll probably just do one of those. So most likely we'll get through it on Tuesday, but like I said, we'll just see where we're at and go from there. But if we get through everything on Tuesday, the quiz will be on Thursday.